Hey guys, today we're going to do a little bit of graphing. I've got a couple of example problems for us to work through. Now it hasn't been that long since we did our graphing chapter, so I bet you're already going to remember how to do a lot of this graphing. This first equation is going to be for a parabola. And remember, the general form for a parabola is y equals a times x minus h quantity squared plus k. And to find your vertex, that's always at the point h comma k. So for this example number 1, our vertex is at 3 comma negative 9. Now the interesting thing to notice is that even though you see a negative 3 in the equation, the vertex is at positive 3. In contrast, for the negative 9, it's the same in the equation and in the vertex. But you guys have seen that a bunch of times, so that's probably very familiar. First thing you want to do for this graph is go ahead and put the point 3 comma negative 9 onto your coordinate axis. And then you've got two choices. You can either make a table at this point, and you could fill it in, or you could use that 1a, 3a, 5a trick, and that should do the trick for us as well. Right one up 1, right one up 1, 2, 3, right one up 1, 2, 3, 4, 5. Same thing, left one up 1, left one up 3, left one up 5. You can connect the dots, and that'll give you your parabola. Now you can see your x-intercepts are at the points 0, 0, and 6, comma 0, so you can throw that onto your graph. Your domain for all parabolas out there, all horizontal or all vertical parabolas have a domain from negative infinity to infinity. Your range is either from k to infinity or from negative infinity to k, the k value that you have in your equation. And really what it depends on is whether your a value is positive or negative. This a value at the beginning, if it's positive, then it's going to be k to infinity. If it's negative, it's going to be negative infinity to k. In this case, the number in front of our x minus 3 squared is a positive 1, so our range is from k to infinity, negative 9, up to infinity. And finally, our axis of symmetry is going to be x equals 3. That's a vertical line over which you could fold the graph and it would overlap with itself. So there it is. And then in terms of filling in the table, you've really got two options. You can either kind of fill it in after the fact, after you've gone ahead and used the 1a, 3a, 5a rule. Your other option would be to use your calculator, and that's totally fine as well. It's really completely up to you. Alright, let's move on to example number 2. Remember, if at any point I go too fast, this is a video, so you just raise your hand and ask for the video to be paused, and that should take care of the problem. We can always rewind as well. Example number 2 is a square root equation. That's y equals a times the square root of x minus h plus k. Looks very similar to the equation we just had. It's just instead of a squared bit, now there's a square rooted part. Our vertex is still at h comma k. So for this particular problem, the opposite of negative 2 is positive 2, and then after the square root we have a 4. So our vertex is at 2 comma 4. Now you can use the 1a, 3a, 5a trick just kind of turned on its side to get a square root equation. Up 1, right 1, up 1, right 1, 2, 3, up 1, right 1, 2, 3, 4, 5. It goes off the graph a little bit. There's nothing wrong with that. You could also fill in your table in the same way. So we have a point 3 comma 5. We have the point, looks like to me 6 comma 6. The point 11 comma 7. And then we don't have anything to put in the last entry. That's okay. There's no x-intercept. For the domain of a square root equation, the domain's the hardest part of a square root equation. You take what's underneath the radical and you set it greater than or equal to 0. So x minus 2 should be set greater than or equal to 0. And you solve it, you get x is greater than or equal to 2. That means that x goes from 2 to infinity with a square bracket at the 2. For your range, it's that same thing again, k to infinity or negative infinity to k. And really what we depend on here, it depends on if the a value at the beginning of the problem is positive or negative. In this case it's positive. We have a positive 1 again. So it's going to be from 4 to infinity. And that kind of makes sense because if you look at the graph, the lowest y-coordinate you ever hit is 4, and it only gets taller from there. The y values only go up from there, so our range is from 4 to infinity, and there's no axis of symmetry. Let's move on to example number 3. Once again, if you need the video paused or rewound, just ask, and that's not a problem. This is an absolute value equation. Y equals a absolute value of x minus h plus k. The beauty of these graphs is they all basically behave the same way in terms of finding your vertex and your x-intercept and all that sort of stuff. Our vertex is going to be at h comma k. And so for this problem we have -1 comma -7, the opposite of the number inside and the same as the number outside of the absolute value bars. So take that initial point of -1, -7, go ahead and put it onto your graph. Now our a value for this problem is 2. That acts as our slope. It's rise over run, so I'm going to go up 1, right 1, point. Up 1, right 1, point. Up 1, right 1, up 2, right 1, put a point. Up 2, right 1, put a point. Up 2, right 1, put a point. The reason is our slope is 2 over 1. Up 2, right 1, and so on and so forth. You can put as many points as you want. You can also go in the other direction. Up 2, left 1, up 2, left 1, and so on and so forth. And once you've had enough, once you've got at least 5 points or so, you can connect the dots using your ID as a straight edge. Don't forget to put arrowheads at the end of your graph to indicate to the reader that the graph goes on forever. My x-intercept, it looks like I have something like -4.5 comma 0 and looks like about 2.5 comma 0. Now my domain for any absolute value equation like this, it's all real numbers, -infinity to infinity. The range continues to follow the same rules that we've just seen for the past 2 examples. So we end up with, it's either k to infinity or it's -infinity to k. And in this case, we go with k to infinity because the number at the beginning of the problem, the 2, is positive. So we've got -7 up to infinity. And axis of symmetry is x equals -1. X equals that x coordinate of the vertex that we were working with. And then, go ahead and pop in here and fill in your table. We have -1, -7 as our vertex, and we can kind of build outwards from there. 0, -5, 1, -3. In the other direction, we have -2, -5, and then -3, -3. Now let's say that, you had a brain freeze or something, and you just, for the life of you, could not remember how to graph an absolute value equation. What I would suggest is turn on your calculator, go to the y equals menu, clear out whatever's in there, and type in the equation. 2 absolute value. The way you get to absolute value is second the yellow key and 0, the number 0. That brings you to the catalog, and you can see ABS right here. ABS stands for absolute value. It's probably one of the hardest equations to graph in the TI-83 because you have to go through a special menu to get to it. But this says 2 times the absolute value of x plus 1 minus 7. Go ahead and click graph. And you can see the picture that the graph generates, or that the calculator generates, is basically the same as the graph that we generated. If you go to second table, you could put in whatever table values you want. And the secret of it is, once you're comfortable making a table, you could really graph any equation out there. Any function that has an equation, you can graph it. Now, if your calculator doesn't let you type, you could always go to second table set. That brings you its second window. The table set menu, if you go down to independent and change over to ask, should work. Okay, next page. Here's 2 unfamiliar equations, 2 to the x minus 7 and 3 log base 2 of x. Luckily, you guys know a lot about how to work with exponential equations, so I think we're going to be just fine here. We've been working with them in class over the beginning of chapter 12, so I'm very confident this will go fine. Like I said, as long as you're comfortable with the idea of plugging into an equation, making a table, you can graph anything. All I'm doing here is taking the equation that was given to us at the beginning of the problem, and I'm plugging in the appropriate x values for the exponent. And we can figure out what each of these equal. So our function is 2 to the x minus 7. Our first table value, I'm putting in -1 for x and figuring out what happens. Now you could do this by hand, but it's also totally fine for you to go into your calculator. 2 caret to the negative first minus 7. Now I know that's going to be -6.5. And you can continue that way using your calculator as a tool to help you evaluate these particular values. And once you've got your set of ordered pairs, just go right into your graph, start putting the points down. Looks to me like I made a little mistake right here with this one. This is 2 to the 0 minus 7. 1 minus 7 is -6. Sorry, just caught that as I was graphing it. Then 1, -5 is another point. And then we've got, let's see, 2, -3, and then 3, 1. Now, the 5 points that I was able to plot just by making a table, if that's not enough to get you a good picture, feel free to go into your calculator, type in 2 caret x minus 7. You can click graph and you can get an idea of what this graph should look like. It's an exponential equation. This curve grows very, very quickly. Very, very fast. It just suddenly shoots up to the right. Like that. Okay, example number 5. We have 3 log base 2 of x. As long as you remember what a logarithm is, this is a problem that you can graph by hand. I'm just going to pick a couple values to throw into my log. You're going to notice that they're all powers of 2. And the reason I'm picking all powers of 2, by the way, by powers of 2, 1 is 2 to the 0, 2 is 2 to the first, 4 is 2 squared, 8 is 2 cubed, 16 is 2 to the fourth. So that's what I meant by powers of 2. But in any case, as long as you remember what a logarithm is, we can graph this without using a calculator. I'll show you how to use a calculator as well, but you could just go ahead and replace all of your x's with the inputs, with the numbers that are being plugged in. And we're going to go off the chart a little bit, but we're going to figure out what each of these equal. Now maybe I should zoom in just a little bit. Might be hard to see from the back of the room. But here's what I've done. I've taken the equation, 3 log base 2 of x. I replaced all the x's with the values that I was plugging in, 1, 2, 4, 8, 16. Okay, just remember what your logarithm actually means, and if you remember what a logarithm means, then you are in good shape for graphing it. So you can see right here, I have 3 log base 2 of 1. Well, think about what that log base 2 of 1. A logarithm is a question, and the question you're being asked is 2 to what power equals 1? And that answer is 0. So 0 times 3 is 0. Next, 3 times log base 2 of 2. 2 to what power equals 2? The answer is 1. And 1 times the 3 that's at the beginning is 3. 3 log base 2 of 4. 2 to what power is 4? The answer is 2. 2 times 3 is 6. 3 log base 2 of 8. 2 to what power is 8? The answer is 3. 3 times 3 is 9. This last one's going to be off the graph, but that's okay. 3 log base 2 of 16. Well, 2 to what power is 16? The answer is 4. 4 times 3 is 12. And that point is well off the graph. But anyway, we could put our first point, 1, 0 on the graph. 2, 3 can go on the graph. 4, 6. And then looks to me like 8, 9 is the last point that we figured out that fits onto the graph. Now, if looking at that set of points that are plotted is not enough to draw a good picture for you, just take that calculator of yours again, and we'll type in the equation. So go to y equals 3. Now we would like to do log base 2 of x. Unfortunately, this calculator does not have a base button. So instead, log base 2 of x needs to be described as log of x divided by log of 2. That's the change of base formula. That allows us to graph the equation. If you click graph, there it is. It's a logarithm graph, and it's kind of just growing up and to the right, but pretty slowly. Now once again, don't forget arrowheads at the end of your graph. And we can move on to example number 6. Now example number 6, there's a couple ways you could look at it. First of all, I look at example number 6 and think to myself, oh, that's a quadratic. I should be multiplying it out using a box. And when you use a box to multiply out x minus 1 and x plus 5, you get x squared plus 4x minus 5. So now we know we have a quadratic, so that means it's going to be a parabola, and we know a ton about parabolas. Now to find your vertex, you've got a couple choices. One thing you could theoretically do is use that negative b over 2a formula that we learned about at the beginning of this chapter. But to be honest, in my opinion, it's really just easier to go into your calculator, type x minus 1 times x plus 5. We already know it's a parabola because we multiplied it out, so now we know what the shape should look like. There it is. We could go to second table, and we could just yank some table values from here. So, I don't know, we have negative 5, negative 4, negative 3, negative 2. We need a couple more points, maybe, no, 0, 1, 2, 3, that should work fine. Maybe negative 1, 0, 1, something like that. Okay, we have a set of points from our calculator that we can plot. It's negative 5, 0. That's our first one. Then negative 4, negative 5. After that. And then after that, negative 3, negative 8. Negative 2, negative 9. Negative 1, negative 8. 0, negative 5. And then 1, comma 0. You can see that our x-intercepts are at 1, comma 0 and negative 5, comma 0. That makes sense because we were given a factored form of a quadratic in this problem. X minus 1 times x plus 5. If we set each of those equal to 0, you could see what you end up getting is x equals 1 and x equals negative 5, just like you might expect. Our vertex in this picture is at negative 2, negative 9, negative 2, negative 9. You could throw some extra points into here. Negative 1, negative 8, 0, negative 5. In the other direction, negative 3, and negative 3 and negative 8, and negative 4, negative 5. For your domain, this is a parabola, and parabolas, vertical parabolas, their domain is always, always, always all real numbers. So negative infinity to infinity. For your range, remember it's that k to infinity or negative infinity to k sort of deal. Our a value yet again is positive, so our range is going to be k to infinity. So we've got negative 9 up to infinity. Axis of symmetry is x equals negative 2. It's an equation for a vertical line, the axis of symmetry, and an equation for a line has to start with an x equals or y equals in the traditional sense. Okay, and then finally number 7, I'm going to solve this 3 different ways. When you are asked to solve a system, when someone says solve the following system, what they mean is graphically you're finding the intersection between the two lines, the places where the two lines hit. And so we can go onto this graph here, and let's see, y equals x minus 3. Remember that we have y equals mx plus b is slope-intercept form. B is your y-intercept. M is your slope. So for y equals x minus 3, we have a y-intercept of negative 3. And then up 1, right 1 point, up 1, right 1 point, so on and so forth. You're going to put a lot of points because you don't know where they're going to end up intersecting. And then you could use a straight edge to connect the dots. by putting all those exact points, we're going to find the exact point of intersection. And then for y equals negative x plus 5, we're going to go up to our y-intercept of 5, down one, right one point, down one, right one, so on and so forth, until we find that intersection. And it looks like we already found it. Notice that I'm extending these lines across the entire coordinate plane that was given to me, and also I'm remembering to put arrowheads at the end of my lines. And then you can see right here, graphically, our vertex is 4, 1. So graphically, a solution to a system of equations is an ordered pair where the two lines hit. Now elimination. Elimination means you can add the equations together to get new equations. You try to eliminate a variable. So I can add the two equations. Y plus y is 2y. X minus x is 0. Negative 3 plus 5 is 2. So 2y equals 2, or y equals 1. Now what you could do is you could take that y equals 1 that you found, and you could plug it back into either starting equation that you would like to. I'm going to plug back into this first one just because it looks a little simpler to me. So I'm going to take y equals x minus 3. I'm going to replace y with 1. And you end up getting x is equal to 4. Oh, x is 4, y is 1, just like we got graphically. So graphically, point of intersection, elimination, you eliminate a variable, solve for the remaining variable, plug back in to get the first variable that you eliminated. Substitution now, y equals x minus 3, y equals negative x plus 5. I'm going to purposefully overcomplicate this problem. I'll show you a shortcut in a second, though. I'm going to solve this first equation for y. So I'm going to, for x, I apologize. So y plus 3 is equal to x. Here's what I can do. If I know that x is equal to y plus 3, well, in my other equation, if y is indeed equal to, if x is indeed equal to y plus 3, in the second equation, I can replace x with y plus 3. So I have y equals negative parentheses y plus 3 plus 5. Distribute this negative here. So negative y minus 3 plus 5. Looks like 2y is equal to 2, y is equal to 1. Oh, and just like we had before, if y is equal to 1, that's going to end up giving us that x is equal to 4. So we have the solution of our system is 4, 1. Now, one other way that you could go about substitution on this problem, notice that these two original equations are both equal to y. If both of these equations are solved for y, well, the y's are equal, so therefore the x minus 3 and the negative x plus 5 must also be equal. So then 2x and 8, x is equal to 4. When you plug back in, you're going to get y equals 1, and you're going to get that same point yet again. That 4, 1, you can get it in a multitude of different ways. Okay, I hope this video was helpful, and good luck getting your work done this weekend, and I will see you guys on Monday. I look forward to answering more questions for you.